completely logical and normal and healthy for scientists to disagree. But the nice thing is that, you know, the truth always wins, and so whatever the sun's going to do, it's going to do, and we'll know very soon, probably easily within the next year. So I don't think we're going to a grand, I mean, our grand solar minimum phase, we're already in. You know, but that only means that the solar cycles get smaller. Doesn't mean they go away completely. And so it's a modulation of the solar cycles that are already happening. But as we know, it's the asymmetry of the northern and southern hemispheres that cause the problem magnetically. And so when they're out of phase like they are now, that's a grand solar minimum. But the problem is with that comes a more complicated magnetic field on the sun. And what comes with that are more things like Carrington class events. Because you get a more complicated magnetic field, you get more unstable sunspot groups coming up. Because you're getting hemispheric band compression and all these weird things that are going on that make the sunspots more like bad actors. So just in this last solar cycle, we've had two, if not three, Carrington class events. Only one grazed Earth. And I'll talk about that in the next, well, no, I won't. I talked about that in my CME course, the last of my CME courses. I talked about it. This was the CME that was shot away from Earth. It was actually shot like this. The sun was pointing this way. It was shot out that way, and the bullet that came from the gun, if you can look at it that way, was so big, it actually grazed Earth, if you're Earth. I mean, this thing was massive. This thing was also the one that caused the largest radiation storm on Mars. So, you know, Carrington class events can occur with small cycles, and there is evidence that they occur more often with these low activity cycles than with the big activity cycles. So even if being in a grand minimum doesn't guarantee that you're safe from big events. As a matter of fact, it may be the opposite. And it also causes problems because now we're being bombarded by cosmic rays a lot more than we ever used to. And we're having to deal with that aspect, especially with airlines. And now if we're going to go to Mars, this is the worst time to go to Mars. The cosmic ray impingement is 30%, if not higher, than what it's ever been during the solar, what we call the grand maximum period. So this is the worst time to go to Mars, even if it is a shorter shot, you know, because of the planetary alignment. The thing that you have to understand about space weather is that there is no good time for space weather. When the sun quiets down, cosmic rays get worse, and the big extreme events get worse. When the sun gets more active, cosmic rays quiet down because the sun shields us from them. But there's more activity, so there's more events happening. You know, it's just, there's always something hazardous in space weather. So hopefully that answered that question. As Earth goes through a pole shift and the magnetic field diminishes, how much more susceptible are we to CMEs and cosmic radiation? Oh, well, again, a bit more, then that goes beyond this course. I promise I will do a course on that. But I'm not going to do that until after I get through radiation storms and the rest of these solar flares. And then I'll talk about probably coronal holes, and then I'll get into Earth and some of the issues with the Earth dynamo. There is a primary cause of the sun's dynamo. There is a primary cause of Earth's geological motion and earthquakes. And those primary causes have not been sussed out very well yet. The models that we have that could capture what those primary causes are and subtract them out of the equation don't work very well. And until we can get those models working well, we can't subtract out those primary effects to get to the lower level effects, which are things like tidal forces, right? It's the funny thing to me is that everybody talks about, for example, with earthquakes on Earth, everybody talks about how the sun is affecting those earthquakes, and sun is and Jupiter and Mars and all these planetary alignments. And it's like, well, what about the moon? The moon has by far the strongest tidal influence on Earth that there is, and yet we still can't find a really tight and ironclad connection between the lunar tidal forces and earthquake activity. And if we can't even do that, why would we dream that we could do it with the sun and these other planets that are so much further away and have so much of a weaker influence on Earth? You know, so do I think the effects are there? Sure. Do I think that we have any chance of quantifying what those effects are yet? No, not a chance. And this is why mainstream science steers away from those questions. There's lower lying fruit for them, lower hanging fruit that they need to get and solve before they can tackle these much harder problems. And sometimes I think the Fringe Science Society thinks that that means we're poo-pooing it, that it doesn't exist. No, we're not. We just can't answer the question, you know. Give us a chance to try to solve the easier problems first before these harder problems become the main things that we go after. I mean, it's I won't even get into it, but it's the same thing with the sun and the tidal forces. It's the same problem that we have with space weather and earthquakes, is that the science just isn't there yet. And so yes, could there be correlations? Sure, why not? We just don't have a ghost of a chance of quantifying them. And I'm not sure when that time will be, especially when it comes to the sun and the solar dynamo. Solar dynamo is really complicated. We do think that there are, you know, the team at UCAR and NCAR are doing an amazing job because they're looking at so many other things other than sunspots. They're looking at, obviously the underlying magnetic field, but they're looking at coronal holes. They're looking at how filaments migrate, what we call rush to the poles. They're looking at bright points, not just plages, but the small bright points and the butterfly diagrams that are associated with them. They're looking at all sorts of things that most scientists don't look at when they look at the solar cycle. Most scientists just look at the sunspots. But these people are actually, this team is actually trying to configure the whole thing and get the big picture. And I think they're much closer to finding the truth when it comes to how the solar dynamo works than probably any other team. But they're almost considered fringe, sadly, by the mainstream scientists who have these old theories that they don't want to let go of. For obvious reasons. There's lots of good stuff in those theories. So when a new mainstream science team challenges the old ideas, it's hard to get it adopted. So, for instance, my good colleague, Dr. Scott McIntosh, he's been fighting the good fight for a long time, for years and years, to try to get some of his papers accepted, and they don't want to. You know, there's people who have had have kept him out of certain journals for a year and a half, working on some of these papers, simply because they don't want to change their ways. So anytime people in the fringe science, by the way, fringe science community think that mainstream science doesn't have the same problems, that we're all one big happy family, you're completely wrong. We do the same thing in mainstream science. There are people who have new theories, and it's really hard to get the new theories into the fold and accepted. And fringe science is just another chapter of that. So this is why it kind of boggles the mind to me that people fight so much between mainstream and fringe, because we're really all one family. And we got to help each other and stop fighting each other. Isn't that where the scientific method should rule? If it's reproducible, shouldn't that be convincing to the mainstream? Oh, right, sure, in an ideal world, but you think scientists don't have egos? You don't think scientists have empires that they've built on a particular theory and philosophy, and that if they're wrong, their entire empire crumbles? Come on. They're still human, and they still have mouths to feed and money to make and proposals to write and grants to get and you know, reputations to protect. So they're just like anybody else out there. I mean, you know, the funny thing is I work in music and I work in science, and I remember looking at the two and seeing the squabbles and the egos, and I'm like, geez, you know, this scientist over here has lead singer's disease, and this scientist over here has lead guitarist disease, and you know, and it's like everybody wants their fader higher in the mix. And it's exactly the same way in the scientific world too, is that, you know, everybody wants to hear their voice the loudest. And so it was amazing to me when I realized how similar the two crowds were, because it just let me know that humans are humans, and it doesn't matter what field you're in. So anybody who's a shoe salesman, the people that you deal with day in and day out aren't going to be much different than the attitudes you deal with in science. I hate to say it. So, you know, I mistakenly got into science because I thought that maybe people were going to be seeking the truth more and being more honest when it comes to, and more open-minded when it comes to new ideas, and that the truth would be the one, you know, torch that they'd hold out above everything. And it's just not true. And it's not necessarily because people are evil. None of the scientists are evil. They just honestly have those biases towards their own material, right? They've got to be the best. I mean, how else do you think they got to where they are? And so it's just the same thing that you see anywhere else in the world, in any other profession. And just apply what you already know about life and about people to the scientific community. And it's amazing how unromantically how unromantic an answer that is, but it is absolutely the truth. So yes, we struggle even in mainstream science to get new theories and things adopted. It's not an easy task. Look at Parker, Eugene Parker, right? When he put the whole model out for the solar wind, you can go find, because of Parker Solar Probe, you'll find a whole historical perspective on it. He was ridiculed for decades for his model, and he almost didn't get it published. And this is just the way it is in science, Fringe becomes mainstream, but only typically after decades of fighting. And of course, the theory has to be sound, because only a sound theory will withstand decades of fighting. So it's there's checks and balances. Anyway, it's almost like politics nowadays. Okay, some scientists are evil, like the brain and Pinky. Oh, geez, you guys are funny. Okay, yes, funding in tenure is a political process, unfortunately. Exactly, it really is. And it's become even more politicized, and that's part of the reason why I wanted to start this field, was because if we can get space weather into a broadcast medium, and it becomes more something that is part of our everyday weather, then a lot of this fighting, a lot of this infighting because the funding is limited, because the field is so obscure, some of that goes away. Because now it becomes part of weather. More people want to do it, granted, but also there's more money to do it with. And that, I think, is really going to be the big normalizing factor when it comes to space weather, is if we can pull it into terrestrial weather, we're going to solve a lot of problems. We may create a few more, but we're going to solve a lot of them. And also we're going to do a huge benefit, there's going to be a huge benefit to society, especially as we become more spacefaring. Because like I said, I've used the word cavalier far too many times today. And I use it pretty much every time I teach a course, because there's so many examples of where we are being cavalier in our race to space, and now our new race to the moon and to Mars. And we're not paying attention to the details, and the devil is always in the details. So, okay, King of the Mountain principle, yes. The irony, truth is in people as scientists with biases, it trumps truth, yes. It's just the way it is for human nature. Religion more so. Well, science becomes religion, right? Depending upon how you define the religion, scientists, they have their own religions. So, okay, what is your opinion of Dr. Zarkova? Right. Well, she's, the nice thing is that we're all going to know within the next year if solar cycle 25 comes on time, Zarkova is going to be, wrong. And I personally, I think Zarkova is wrong, and I think solar cycle 25 is coming. We've already seen evidence of it, so I do believe it's coming, and I do believe that that the methodologies are used is limiting, and is not considering everything. But I, as a scientist, I have my reasons for saying that, and I'm not gonna say that Zarkova is not a reputable scientist just simply because there's a difference of opinion here. That's the one thing that good scientists do not smear other scientists simply because they disagree. It's